Good afternoon. My name is Paul Sabanal, and this is Mark Yason. We both work for IBM ISS X-Force. Today, we're going to talk about reversing C++ applications. Okay. Reversing C++ is notorious to be very hard to do and tedious and time-consuming. Our main motivation for this talk is the general lack of publicly available information regarding this subject. As reversers, our day-to-day job involves analyzing malware and analyzing vulnerabilities. And nowadays, use of C++ code in malware are increasing. The more famous examples would be Agabot and MITOP variants. So as reversers, we have to know how to reverse malware compiled in C++ to be able to do our job effectively. At the same time, the most modern applications nowadays use C++. So if you're doing binary auditing or you're doing vulnerability analysis, you have to know how to reverse C++ to be effective. In this talk, the purpose of this talk is to understand C++ concepts as they appear in the disassembly, and to have a big picture idea on what the major pieces of the classes or the major pieces of the C++ target and how these pieces relate together. In this talk, we will focus on identifying classes, identifying the relationships between classes, and identifying the class members. Oops, please wait a minute. Apparently I opened the wrong slide, so I have to open another one. Sorry about that. It's an old version. Okay. We're not going to discuss the more obscure C++ features, since when we're doing this, even this three is hard enough to do or hard enough to analyze. So we are going to reserve that for a future talk, maybe. Also, please note that we're only going to discuss the Microsoft Visual C++ compiler. Other compilers, such as GCC, would have different implementation, but since they are compiling the same language, obviously, there will be some similarities. So we believe that it will also help you. This talk will also help you in doing reversing of GCC compiled C++ binaries. First, we're going to discuss the manual approach, and then we're going to discuss how to automate the tedious task related to this activity.
So the first thing you'll need to do is to identify if the binary is a C++ compiled binary. So when you load compile the C++ binary in Eda Pro, you see a heavy use of ECX. So ECX is used as a disk pointer. So, for example, in the first example, you will see a parameter being pushed in the stack, and ECX is initialized with a specific value. So another thing you can look at is the function. As you can see in the entry of the function, ECX is used before a value is stored in it. So in this particular example, so it moved the value of ECX, which contains the disk pointer, and then probably try to specify the virtual function table as the first D word, and then on the second D word, the second D word is probably a variable. So like before, ECX will be the parameters on the stack. The parameters are passed on the stack, and the ECX pointer will have the this pointer. So this is an example of an indirect function call. As you will see, it will first create an object using new, and then put it in EAX. And then what it will do next is to get the first D word, and then try to call the first D word pointed by this pointer, which points to the virtual function table. So another thing to look at is if on a compiled C++ binary, you will see that you will recognize that some STL code and some like this one, which uses the basic stream buff class.
Okay, one of the most important things that you have to know when you're versing C++ applications is how the object is laid out in memory, or its class instance layout. With your own programs, you can actually see how the classes that you make are laid out by using the -d1 report all class layout switch for cl.exe to dump the layout in SCDS in the standard output. So in this example, I have here a class x1. This is a very simple class. It has 3 member variables and 1 non-virtual function. So how would this appear in memory? As you can see, it only stores its 3 member variables, with the last one being a character type. It will be a padding will be added to align it. And for classes that contain virtual functions, a virtual function table pointer will be added before the class members in the layout. The virtual function table pointer points to the address of the virtual function table. In this case, since we have 2 virtual function get sum reset values, and they will appear as they were in the order they are declared in the class declaration. So what if the class inherits from another class, from one class? In the example, the class x3 inherits from the class in the previous slide, x2. Class x3 has 1 member variable. So what actually will happen is that if you inherit from another class, its class instance will be embedded into the derived class instance, and it will be placed before the derived class own instance data. So as you can see, the previous layout that I showed for x2 is embedded before var2 in x3's instance layout. If a class inherits from more than one class, this will happen. In this case, we have class x5, which inherits from class x2 and class x4. So as you might have guessed, the same thing happens. The base class instance data are embedded inside the class x5's class instance layout. If you may have noticed, class X5's virtual function table pointer is not present. And that's because there's a rule that if there's no virtual function table for the virtual function table is only added to the derived class if there is no virtual function in the base classes. And you also notice that func1 in x5 overrides class x4's func1. So what will happen in the virtual function table? Okay, here's the virtual function table for x5. As you can see in the second group, what's supposed to be x4's func1 was replaced by the pointer to x5's func1. Now, please remember this layout because it's very important when analyzing in the later discussions. Now, how do we identify the classes? Our manual approach entails, we first search for constructors, and we assume initially that each constructor corresponds to one class. Of course, it's not always true because a constructor can be overloaded. So there could be more than one constructor for a particular class. But initially, we don't have to worry about that. We can correlate that later by seeing if several classes has common member functions. If they have, it is probably an overloaded. It is probably the same class with an overloaded constructor. So to be able to identify to be able to look for constructors, we have to know how objects are instantiated. There are three common types of objects in C++. One's global object, and the local objects or the stack objects, and dynamically allocated objects. For the global objects, these objects are declared as global variables, and they're allocated like all global variables in the data segment of the program. The constructor for global objects are called at program startup, and the destructor is called program exit. One way to find the constructor and the destructor for a global object is to identify parameters to these functions, underscore cinit and underscore at exit. Here's an example of global object. And here you have to analyze cross references to where the global variable is stored in the data segment to be able to look for the constructor. Now, local objects, on the other hand, are allocated in the stack. The constructor is called upon the declaration using an initialized stack variable as the dispointer. You have to look for the constructor. Look for load to ECX using a stack variable as a source, that stack variable has to be used for the first time at that point. It has to be empty. The destructor is implicitly called when object is out of scope. For example, if you declare an object inside an if clause, once you exit that clause, automatically that object will be destroyed. And or for example, if you're inside a loop, you declare an object inside a loop. When you get out of the loop, the object will be automatically destroyed. Here's an example of that in the disassembly. This is actually an if statement, and the block begins over. In the first red line, the constructor for that object is called.